Good morning, everyone. I am Aditya Hegde from the Department of Artificial Intelligence and Data Science. Today, I will be presenting our B project titled Dynamic Allocation of Spatial Spectrum for 6G using Agentic AI and RAG. This work is guided by Dr. Anjali Yoile and developed by our team. So, to start with, let's understand what the actual problem is. When we say spectrum scarcity, we usually think there isn't enough spectrum, but in reality, it's more of a distribution problem. Cities are overloaded, while the rural areas have unused spectrum, and the current systems are static, so they don't react to the real time demand. Also, AI systems often act like a black boxes, so we don't know why the decisions are made. So the challenge is, can we make it dynamic, fair, and explainable? Another issue is trust. If a system makes decisions but cannot explain them, people hesitate to rely on it. So explainability becomes very important. Let me explain with a simple example. A rural hospital in Mizoram, during an emergency, a doctor tries to make a call but it fails. Not because the spectrum is unavailable, but because it is allocated elsewhere. So the system fails where it mattered the most. Our system detects this demand, reallocates a new spectrum, and ensures the call goes through. And it also explains why the decision was taken. This is not just technical, it affects the real world areas like healthcare and emergency response. We are trying to reduce the digital divide. The idea is simple. Resources should go where they need it the most. We divide the system into multiple agents. Each agent has a role. One controls the decisions, one ensures the policies, one allocates the spectrum, one ensures the fairness, and one monitors the system. So instead of one model, we have a collaborative system, and the RAG adds the explanation capability. So in methodology, we used a large data set from across India with the parameters like bandwidth and QoS. We trained a multi-agent reinforcement learning model where the agents learn from the interactions. So the system improves over time and the RAG generates explanations in simple terms. Now this diagram shows the complete working of our system. Let me break it down step by step so it's easier to understand. First, on the left side, we have the user interface and the dashboard, which displays the important metrics like spectrum usage and performance. Below that, we have the RAG console, which is responsible for generating explanations. So whenever a decision is made, this module retrieves the relevant information and explains it in a simple language. Now coming to the center, this is the core of our system, the agentic workflow. At the top, the master agent coordinates everything. It basically decides what needs to be done. Then the agent goes to Policy Guardian, which checks whether it follows rules and regulations. After that, the Smart Allocator performs the actual spectrum assignment. Then comes the Fairness Agent, which ensures that allocation is balanced and no region is unfairly treated. Finally, the spectrum monitor continuously checks network conditions and detects if the reallocation is needed. Now, on the right side, we simulate a real 6G environment, including user demand and network conditions. Based on all this, the system produces outputs like heat maps, efficiency charts, and allocation insights. One very important part here is the feedback loop. If a decision is not optimal, it is sent back to the system so that the agents can improve their future decisions. So overall, this entire workflow makes the system adaptive, intelligent, and continuously improving. Now coming to the most important part, the results. We have evaluated our system on multiple performance metrics. First, spectrum utilization increased to around 88.6%, which is significant improvement over all traditional methods. Second, latency reduced drastically, which means the faster communication and better user experience. Third, throughput increased, so more data can be transmitted efficiently. Another key metric is fairness. We achieved a Jain fairness index of 0.93, which is very close to ideal distribution. This means spectrum is not just efficiently used, but also distributed equally across all the regions. We also observed energy savings, which makes the system more sustainable. And importantly, all the decisions were 100% policy compliant, which is critical for the real world deployment. So overall, our system improves efficiency, fairness, and reliability all at the same time. Okay, now this graph shows a comparison before and after applying to our system. Red represents the old approach and the green represents our model. And the key takeaway is allocation becomes more balanced across all the regions. So to conclude, we developed a system that is dynamic, fair, adaptive, and explainable. And this is essential for all the future 6G networks. Okay, that's all from my side. Thank you, everyone.